We're going 36,000 feet down. Close your eyes for a moment and try to imagine this. A darkness so complete, so absolutely impenetrable, that it makes the darkest night you've ever experienced seem like a summer midday. We're not talking about turning off the lights in your room or entering a cave. We're talking about a type of darkness that has existed for millions of years, where sunlight has never, ever, in the entire history of Earth, managed to penetrate. Now add to that the weight of an entire ocean stacked on top of you. The pressure down there, at 7 miles deep, is more than 1,000 times greater than what we feel here on the surface. To give you a real sense of what that means, imagine 50 fully loaded jumbo jets stacked on top of each other, and all that weight concentrated on an area the size of your thumbnail. It's a force so colossal, so incomprehensible, that it crushes metal like aluminum foil, crumpled by a child. Battle tanks built to withstand direct explosions, imploded instantly. Nuclear submarines with titanium hulls designed for deep military dives, crushed like empty soda cans before even reaching halfway. For decades, the international scientific community was virtually unanimous in a frightening conclusion. Nothing, absolutely nothing, could live in that frozen, pressurized hell. The most respected marine biologists in the world confidently declared that the Mariana Trench was a biological desert, a final point on the map of terrestrial life. It was considered the biological equivalent of absolute zero, a place where the very laws of biology simply didn't apply. Textbooks taught this as established fact. Universities preached it as absolute truth. Case closed. End of discussion. But they were completely, absolutely, spectacularly wrong. The truth about what exists in the deepest place on the planet isn't just surprising. It's something that defies everything we thought we knew about the limits of life. What explorers found when they finally managed to get down there not only proves that life is infinitely more resilient, more adaptable, and more ingenious than we ever dreamed, but it seems to have come straight from the pages of a cosmic horror novel written by H.P. Lovecraft. We're talking about creatures that look like translucent ghosts floating in eternal darkness, microscopic monsters that build metal armor from seafloor mud, organisms that are literally one single giant cell the size of a tennis ball. Mentally prepare yourself, take a deep breath, because we're taking you on a vertical journey through 7 miles of water to an alien realm that fewer people have visited than have walked on the surface of the moon. A place that completely rewrites the rules about where and how life can exist. And here's the most disturbing part of all. This isn't science fiction. This isn't a distant planet orbiting an alien star light years away. This isn't an icy moon of Jupiter or Saturn. This is Earth. This bizarre world, this gallery of biological horrors and wonders, is right there, just a few hours by boat from the coasts of the Mariana Islands. It's literally beneath our feet right now, existing in crushing silence and perpetual darkness that has never known a single ray of sunlight. As you read these words, bizarre deep-sea creatures are hunting, surviving, and thriving in an environment that should be totally impossible for life. The Mariana Trench isn't just the deepest point in the ocean. It's a window into a parallel universe of biological possibilities that science is only beginning to scratch the surface of. And what we're going to discover together in the next few minutes will completely change your perspective on what lies at 7 miles deep, and on the very meaning of the word impossible. There's a phrase we've all heard repeated so many times, it's become almost a cliché. We know more about the surface of the moon than about the bottom of our own ocean. And you know what's scarier? That's not just an expression for effect or poetic exaggeration. It's literally, mathematically, scientifically true. We have detailed maps of Mars, we can identify individual craters on the surface of Venus, and we've placed probes in the icy reaches of Pluto. But when it comes to the oceanic abyss of our own planet, we're still essentially in the dark. And nowhere is this disturbing reality more frighteningly evident than when we talk about the Mariana Trench, the deepest, most mysterious, and most inaccessible point on the entire planet Earth. This isn't just another interesting location for National Geographic documentaries. This is the oceanic equivalent of an entire other planet, hidden in plain sight. Located in the western Pacific Ocean, east of the Mariana Islands, from which it gets its name, the Mariana Trench isn't just a deep hole in the ocean floor as some might imagine. No, this is a giant, violent scar in Earth's crust itself. A geological wound over 1,150 miles long. That's approximately the distance between Lisbon and Moscow, or between New York and Denver. For you to truly comprehend the absolutely insane scale of this fissure in our planet, let's do a mental exercise that will blow your mind. Take Mount Everest, right? The highest mountain on the planet. That legendary peak in the Himalayas, where only the bravest and most prepared climbers in the world can reach, where the air is so thin you need oxygen bottles just to breathe. Everest scrapes the sky at an impressive 29,032 feet above sea level. Now mentally, take that entire mountain, rip it from the earth, turn it upside down, and plunge it completely into the Mariana Trench. Know what would happen. Everest's peak, even with all that monumental height, would still be submerged and covered by more than 2 complete miles of freezing water above it. Think about that for a second. A mountain that takes weeks to climb would be completely invisible, drowned in the depths. The maximum depth recorded with precision in the Mariana Trench, a specific place that was named Challenger Deep in honor of the British ship HMS Challenger that first mapped the area in 1875, reaches a staggering 35,876 feet, almost 7 miles of pure water stacked vertically. To put that another way, a Boeing 747 commercial aircraft flies comfortably at a cruising altitude of about 33,000 to 36,000 feet above the surface. The Mariana Trench is the perfect inverted reflection of that, but instead of thin air and blue sky, you have pressurized water and total darkness. It's literally as if nature created a mirrored world, dark and crushing, right below us. The first scientists who tried to measure these depths in the 1950s simply didn't believe the numbers. They thought their sonar equipment was defective or miscalibrated because the readings that came back were, frankly, impossible to accept. In this incomprehensible abyss, the basic rules of life as we know them simply don't apply. Sunlight, which is literally the primary source of energy for approximately 99% of all life on Earth through photosynthesis, is a distant and irrelevant memory. It disappears completely around a mere 3,300 feet depth, and we're talking about reaching 36,000. That means there are over 6 complete miles of ocean below the point where the last particle of sunlight can penetrate. From there down, you have an eternal, absolute, and impenetrable darkness that has existed for literally millions of years without interruption. It's not just dark like your room at night. It's a primordial darkness that has never, ever since the beginning of time been touched by a single photon of sunlight. The water temperature constantly hovers just a degree or two above freezing, about 34 to 39 degrees Fahrenheit. It's a perpetual, constant, and relentless cold that has never experienced, not even for a millisecond, the comforting warmth of the sun. And then, as if total darkness and freezing cold weren't enough, we have the pressure, and this is where things get truly insane. There's a simple rule in underwater physics that every diver learns on day one. For every 33 feet you descend, the pressure increases by 1 complete atmosphere. Sounds harmless when you're going down 33, 66, maybe 100 feet on a recreational dive. But now do the math for 36,000 feet. We're talking about more than 1,000 complete atmospheres of pressure. 1,000 times the pressure you feel right now sitting comfortably in your chair. To make this visceral and real, imagine literally the weight of 50 fully loaded Boeing 747 jumbo jets with passengers, luggage and fuel all stacked vertically on top of each other, and all that apocalyptic weight concentrated and balanced on the tip of your pinky finger, or as oceanographic scientists love to describe more terrifyingly, it's like having 3 adult African elephants standing, perfectly balanced on top of a single postage stamp. It's a force that doesn't just crush objects, it literally alters the very chemistry and molecular structure of substances, changing how atoms behave and interact with each other. The question that tormented, obsessed, and kept entire generations of marine scientists, evolutionary biologists, and oceanographers awake for more than a century was brutally simple, but profoundly frightening. What kind of life, if any form of life at all, can not only survive but thrive in these literally hellish conditions? Because, you see, we're not just talking about difficult conditions, like a hot desert or Arctic tundra. We're talking about an environment that simultaneously combines perpetual total darkness, extreme constant cold, apocalyptic crushing pressure, and almost absolute food scarcity. It was reasonable, even logical, to assume nothing could live there. The answer, as you're about to discover in the next sections of this journey, is so crazy, so absolutely bizarre, so counterintuitive, yet at the same time so deeply inspiring that it will make you completely rethink what it means to be alive on this planet. The Mariana Trench creatures that inhabit the deepest place on Earth are living witnesses that life always finds a way, no matter how impossible that way may seem. The Mariana Trench isn't a random geological accident, nor a simple hole that appeared by chance on the ocean floor. No, this is the direct result of one of the most powerful, violent, and inexorable forces that exist on our planet, plate tectonics. Imagine Earth's crust not as a solid, immobile shell, but as a giant puzzle of moving pieces floating on a mantle of molten, incandescent rock. These plates are constantly in motion, pushing against each other, sliding laterally, or moving apart in super-slow geological motion. The Mariana Trench is what geologists call a subduction zone, and that technical name hides brutal violence. Here, the giant Pacific Plate, one of the largest and oldest oceanic crusts on Earth, is literally diving and sliding beneath the younger, lighter Mariana Plate, being swallowed back into Earth's mantle. It's the planet literally devouring itself, recycling its own skin, in a process lasting millions of years. This colossal movement, which continues happening this very second as you read this, not only creates the world's deepest trench, but is also responsible for forming the arc of volcanic Mariana Islands. Those islands are literally the byproduct of this slow-motion tectonic collision, magma forced upward by the incomprehensible pressure of colliding plates. Getting down there, to the bottom of this geological scar, is a technological and engineering challenge as monumental and complex as, and many would say even more difficult than, putting a human on the moon's surface. Think about it for a moment. In the vacuum of space, the great challenge is keeping air pressure inside the spacecraft, creating a small cocoon of breathable atmosphere surrounded by the deadly vacuum of the cosmos. At the bottom of the abyssal ocean, the challenge is exactly the opposite and, in a way, even more brutal. You need to prevent the absolutely crushing external pressure from entering and crushing everything and everyone inside the submersible. A conventional military submarine, even the most advanced nuclear models designed for deep-water espionage operations, would be completely crushed, imploded like a stomped soda can long before reaching even a third of the way to the bottom. The reinforced titanium and steel hulls that seem so impressive and indestructible on the surface simply can't hold up. That's why there's an absolutely shocking statistic that should make you stop and think. To this day, in 2025, more human beings have walked on the moon's surface, a total of 12 astronauts during the Apollo missions, than have personally visited the deepest point on our own planet. Let that marinate for a second. It's easier, from a statistical and logistical standpoint, to travel 238,855 miles through space vacuum to another celestial body than to descend 7 miles vertically through the water of our own ocean. The first time humanity managed to touch the bottom of the world, reach that deepest point and return to tell the story, was on a date that should be as celebrated as the first moon landing, January 23rd, 1960. Swiss oceanographer and explorer Jacques Piccard, son of the brilliant inventor Auguste Piccard, along with U.S. Navy Lieutenant Don Walsh, two absolutely courageous, or crazy, depending on your perspective, men boarded a machine that seemed to have come straight from the pages of a Jules Verne novel, the bathyscaphe Trieste. This wasn't a submarine in the traditional sense. It was essentially an ultra-resistant steel sphere, the cabin where the two men were crammed, literally hanging by cables beneath an enormous float tank filled with gasoline to provide buoyancy. The descent was an agonizing journey through total darkness that took almost 5 complete hours of constant vertical descent, each minute taking them deeper into an abyss where no human had ever been. About 30,000 feet below the surface, still more than a mile from the bottom, they heard something that froze the blood in their veins. A deafening crack, loud as a rifle shot, that reverberated through the entire metal structure and made the whole sphere vibrate violently. One of the outer reinforced acrylic windows had developed a crack under the absolutely monstrous pressure. At that moment, they faced a terrible choice: abort the mission and begin the slow climb back to safety, or continue descending into the unknown with a compromised window that could implode at any second and kill them instantly. They chose to continue, a testament to both human courage and obsession with discovery. When they finally touched the muddy bottom of Challenger Deep, Piccard and Walsh stayed only 20 minutes in that alien world, barely enough time to turn on the external lights, look through the fogged window, and make basic observations. But those 20 minutes changed everything. They saw, with their own incredulous eyes, something the entire scientific community had declared impossible: a flatfish similar to a flounder and what appeared to be a shrimp, swimming calmly on the seafloor as if that apocalyptic pressure were the most normal thing in the world. That simple sight, those two small animals surviving where nothing should survive, proved definitively and irrefutably that complex macroscopic life could not only exist, but thrive under pressures that would literally crush steel. It was one of the most important biological discoveries of the 20th century, and it happened in the blink of an eye at the bottom of the abyss. But after that historic mission, silence. The Trieste never returned. The technology of the era simply didn't allow regular explorations. The Mariana Trench returned to being an unexplored mystery, guarding its secrets in the depths. It took more than 50 years, half a century of technological advances, computers, new materials, the space age, and the internet, for another human being to gather the courage, money, and technology necessary to make that impossible journey again. On March 26, 2012, Canadian filmmaker James Cameron, yes, the same man who gave us epic films like Titanic and Avatar, a visionary obsessed with both the ocean and exploration, did something even more audacious and solitary than Piccard and Walsh. He descended alone to the bottom of the Mariana Trench. His submersible, painted bright lime green and called Deep Sea Challenger, was an absolute masterpiece of modern engineering, designed to descend vertically like a human torpedo, and equipped with high-definition 3D cameras, robotic arms for sample collection, and powerful LED lighting. Cameron spent almost 3 hours on the bottom, alone with his thoughts in a steel cocoon just 43 inches in diameter. Imagine being crouched in a sphere smaller than a phone booth for hours, filming extensively and revealing to the world for the first time a desolate but geologically fascinating landscape of grey mud, rocks, and yes, life. Those high-definition images from the abyss were absolutely revolutionary and opened the public's eyes to this alien world. And then, more recently still, a Texan explorer and investor with seemingly unlimited resources and unwavering determination entered the scene, Victor Vescovo. With his ambitious Five Deeps expedition launched in 2018, Vescovo didn't just reach the bottom of Challenger Deep multiple times in 2019. He literally transformed what had been a once-per-generation feat, something that happened once every 50 years, into an almost routine and repeatable procedure. He became the first person in history to visit the deepest points of all 5 oceans: Atlantic, Pacific, Indian, Arctic, and Antarctic. His state-of-the-art submersible, the limiting factor, built by Triton submarines with cutting-edge technology, is capable of diving repeatedly to full depths, with 2 crew members returning to the surface and diving again, as if it were almost a taxi to the abyss. This finally allowed marine scientists, biologists, and geologists to study the Mariana Trench consistently and systematically, collecting samples, filming life on the seafloor, and mapping this unknown territory. Vescovo and his team are literally opening a new era of abyssal exploration. These daring and visionary pioneers have opened a small window, a crack of light, into this realm of perpetual darkness. And what's in there, what they discovered swimming, crawling, and surviving in the depths, is absolutely, completely, spectacularly insane. The bizarre deep-sea creatures of the Mariana Trench prove that reality is infinitely stranger than fiction. To truly find and understand the bizarre creatures of the Mariana Trench, those extraordinary beings that defy all the rules of conventional biology, we can't simply jump straight to the bottom like diving into a pool. No, we have to make the complete journey, slowly descending through multiple completely different worlds stacked vertically on top of each other, each layer with its own rules, its own inhabitants, and its own unique challenges. It's literally like descending through the progressively darker and more disturbing circles of Dante's Inferno, but in an aquatic and even more alien version. Each oceanic zone we cross is an entirely separate ecosystem, with creatures adapted specifically to those specific conditions of light, pressure, and temperature. Prepare your mind, take a deep breath, and let's make this vertical journey through the abyss together, layer by layer, diving deeper and deeper into darkness. Let's do this, from 0 to 660 feet, the sunlight zone, epipelagic, the ocean's kindergarten. This first layer is the oceanic world we all instantly recognize from BBC documentaries narrated by David Attenborough, from YouTube videos about marine life, and from our snorkeling dives on tropical vacations. Here, there's abundant sunlight penetrating through the water in golden and blue rays, creating that magical underwater glow we see in photographs. There's relative warmth compared to the depths. Water can reach a pleasant 77 to 86 degrees Fahrenheit in tropical seas. And most importantly, there's photosynthesis happening on a massive scale. This is the domain of microscopic phytoplankton, those floating unicellular algae that, despite being invisible to the naked eye, are responsible for producing between 50% to 80% of all the oxygen we breathe on this planet, more than all the rainforests, savannas, and grasslands combined. These tiny photosynthetic factories form the absolute base of a vibrant, exuberant chain of life. Colorful tropical fish like those we see in aquariums, sea turtles gliding gracefully, dolphins jumping and playing in the waves, seals hunting, sharks patrolling as apex predators. It's the ocean's kindergarten, familiar, comforting, and relatively safe. It's easy to understand and relate to. But my friend, we're only scratching the surface. The real strangeness is still to come, hidden far below our feet. From 660 to 3,300 feet, the twilight zone, mesopelagic, where light begins to die. Welcome officially to the twilight zone, and believe me, the name couldn't be more appropriate and sinister. Sunlight here is no longer that bright, comforting illumination of the surface. It's a pale, weak, agonizing ghost of itself. Solar rays reach here filtered through hundreds of feet of water, transformed into a faint blue-green twilight too weak, insufficient to allow any kind of functional photosynthesis. Marine plants simply can't survive here. Pressure begins to increase significantly. We're talking about 20 to 100 atmospheres crushing anything that descends here. And the creatures start to get truly, undeniably strange. This is the realm of bioluminescence, that absolutely magical yet disturbing phenomenon where the animals themselves produce light through chemical reactions inside their bodies. About 90% of species inhabiting this zone have developed the ability to create their own light. Imagine that 9 out of 10 animals here literally glow in the dark. They use this biological light for surprisingly diverse and intelligent purposes, attracting unsuspecting prey like a glowing trap, confusing and blinding predators with sudden flashes of light, communicating with members of the same species through patterns of blinks like biological Morse code, or finding a sexual mate in the eternal twilight. This is where we find creatures like the lanternfish, small fish covered with light-producing organs, called photophores arranged in unique patterns like living constellations, and the frightening viperfish with its dislocatable jaw full of translucent teeth sharp as glass needles that reflect any faint available light. The twilight zone is where familiarity ends and true deep-sea mysteries begin to reveal themselves. From 3,300 to 13,000 feet, the midnight zone, bathypelagic, the realm of total darkness, cross the 3,300-foot barrier and something definitive and irreversible happens. Darkness becomes total, absolute, complete. There's no longer any trace, no microscopic vestige, no distant memory of sunlight. The only illumination that will ever exist in this black realm are the occasional ghostly flashes of bioluminescence produced by the inhabitants themselves, like alien fireflies blinking in eternal darkness. Water temperature stabilizes at a constant, relentless cold between 36 and 39 degrees Fahrenheit, just a breath above freezing. Pressure in this zone ranges between 100 and 400 atmospheres. Imagine having 100 to 400 times the weight of the entire Earth's atmosphere crushing every square inch of your body. For context, that's enough pressure to compress styrofoam into a dense, solid mass or completely crush a plastic bottle until it's the size of a coin. Welcome to the permanent home of the legendary anglerfish, also known as the deep-sea angler, that creature that seems designed in the most feverish nightmares of a horror artist. With its famous bioluminescent lure, called Esker, dangling like a hypnotic lantern in front of an absolutely cavernous mouth, disproportionate to its body, full of curved, translucent, and deadly sharp teeth. Animals living here are absolute evolutionary masters of energy conservation because food is incredibly, desperately scarce. They've developed extremely slow metabolisms that function as if constantly in battery-saving mode. Soft, flaccid bodies without dense energy-wasting muscles, and disproportionately huge mouths capable of swallowing prey the same size or even larger than themselves, because when food appears, which might be once a month or even less, you need to make the most of it. We're halfway through the abyss, and things only get more bizarre from here. From 13,000 to 20,000 feet, the abyss, abyssopelagic, the underwater desert. This zone's name couldn't be more direct, more honest, or more terrifying. The abyss. The word itself evokes images of infinite emptiness, eternal falling, a place without bottom or hope. And reality doesn't fall far from that. Pressure here exceeds 400 atmospheres and can approach 600. That's literally equivalent to having 40 to 60 adult African elephants stacked on top of every square yard of your body. Think about that. Food in this zone is so extremely, desperately scarce it's almost non-existent. The entire ecosystem here depends almost exclusively on a poetic but frightening phenomenon called marine snow, a slow, constant, perpetual rain of organic debris, particles of feces from animals in the upper zones, discarded mucus, fragments of decomposing dead animals, discarded crustacean shells, all floating slowly downward through miles of water like snowflakes in an eternal underwater blizzard. This snow is literally the only source of nutrients for abyssal life, the remains and leftovers from the world above. Creatures inhabiting the abyss are often gelatinous in texture, because dense muscles and bones require a lot of energy to maintain. Pale or completely transparent due to the total absence of light-making pigmentation, completely useless, and absurdly slow in their movements to conserve every precious calorie. The tripod fish is an absolutely fascinating and bizarre example. It literally stands still on the muddy seafloor, supported on its three long modified pelvic and caudal fins that function like a photographic tripod's legs, completely motionless for hours or even days, waiting with the patience of a statue for some small crustacean or worm to pass by close enough to be captured with a sudden movement. It's an existence that seems almost zen in its forced stillness, a life of involuntary meditation in the dark. And we haven't reached the bottom yet. There's still one final zone left, the most extreme, the most impossible, from 20,000 to 36,000 feet, the Hadal Zone, the underwater hell. We've arrived, finally at the final destination of this descending journey through the oceanic abyss. This is the Hadal Zone, absolutely appropriately named in honor of Hades, the fearsome Greek god of the underworld, the ruler of the realm of the dead in ancient mythology. And truly, if any place on earth deserves to be compared to the mythological underworld, it's this. The Hadal Zone doesn't exist throughout the ocean. It's composed exclusively of the planet's deepest oceanic trenches, those extreme geological scars where tectonic plates dive beneath each other. The Mariana Trench is the undisputed queen of these trenches, the deepest point of all. Pressure here is so absurdly, incomprehensibly high that it exceeds 600 atmospheres at the entrance into the Hadal Zone at 20,000 feet and can easily exceed 100 atmospheres at the bottom of Challenger Deep. To make this more visceral, every square inch of surface here is being crushed by a force equivalent to more than 2,200 pounds. Your entire hand, which has perhaps 15 square inches of area, would be supporting 220,000 pounds of pressure, 100 tons. The environment is perpetually pitch black, frozen at just a few degrees above zero, and food is even rarer than in the abyss, arriving in a microscopic drip of marine snow that takes days to fall from the distant surface. For entire decades, the global scientific community believed, taught, and published in peer-reviewed journals that complex multicellular life here would be physically and biologically impossible. Proteins should denature under pressure, cell membranes should collapse, metabolic processes should simply stop functioning, and yet, against all logic, against all predictions, against everything science thought it knew about life's limits, life here not only exists but is literally thriving, evolving, diversifying into increasingly bizarre forms. The animals of the Mariana Trench prove that life is infinitely more resilient, more creative, and more impossible to kill than we could ever imagine. Welcome to the bottom of the world. Welcome to the home of the strangest creatures in the ocean. It's here, in this frozen and pressurized hell, that true, absolute, incomprehensible biological madness begins. What lives at 7 miles deep will rewrite everything you think you know about life. When most people think of sea monsters, the images that come to mind are usually those legendary, gigantic creatures that populate horror movies and sailors' stories. Colossal squid with tentacles the size of trees, capable of dragging entire ships to the bottom. Or the mythical megalodon, that giant prehistoric shark with teeth the size of human hands that could bite a great white shark in half. They're nightmare creatures, no doubt, but they're also relatively understandable. They're just bigger, scarier versions of animals we already know, but completely forget those Hollywood sensationalist images for a moment. The reality of what lives at the bottom of the Mariana Trench is simultaneously much smaller in physical scale, infinitely stranger in appearance and form, and paradoxically much more fascinating from a scientific and evolutionary standpoint. These aren't creatures designed to scare. They were sculpted by millions of years of brutal selective pressure to survive the planet's most hostile and impossible environment. Each one is a walking miracle of biology, a living testament to the insane creativity of natural selection when pushed to its absolute limits. Prepare to meet the true inhabitants of the abyss, the definitive gallery of bizarre deep-sea creatures that call the pressurized darkness home. Creature 1, the Mariana snailfish, Pseudoliparis swirei, the undisputed champion of extreme pressure. Look at this creature and honestly tell me this looks like something capable of surviving Earth's most hostile environment. It literally looks like an aquatic floating ghost, a translucent apparition from the spirit world that somehow materialized at the ocean bottom. It's small, rarely exceeding 11 inches in length, delicate in appearance, with a pale pinkish coloring almost ethereal and completely devoid of protective scales. The skin is smooth, gelatinous, almost transparent, allowing you to see some of its internal organs functioning as if looking through frosted glass. It seems so absurdly fragile, so delicate and vulnerable that you'd swear it would disintegrate instantly in your hand if you tried to hold it. And yet, and here's the part that will blow your mind, this is Pseudoliparis swirei, officially recognized as the fish that lives and actively thrives at the greatest depth ever scientifically recorded and filmed, captured on high-definition video, swimming happily, hunting prey, and living its best life at a staggering 26,831 feet deep in the Mariana Trench, over 5 miles down below the ocean's surface. Let that number marinate in your mind for a second. The obvious question any rational person would ask is, how does this apparently delicate fish, so fragile, so inadequate for survival, manage to not only survive, but actively thrive under pressure that literally crushes military-grade steel like aluminum foil? The answer is an absolute masterpiece of evolutionary engineering operating on multiple fronts simultaneously. First, the snailfish's entire body is mostly composed of soft, gelatinous tissue, without bulky, dense muscles or heavily calcified skeleton that would waste precious energy and create structural stress points under pressure. It doesn't possess a swim bladder, that air-filled organ most fish use to control buoyancy, because any gas pocket would be instantly compressed and crushed at these depths. But the true secret weapon, the true evolutionary masterstroke of Pseudoliparis swirei, is completely invisible to the naked eye and operates at the cellular-molecular level. This fish's cells produce in massive quantities an organic molecule called trimethylamine oxide, often abbreviated by scientists as TMAO. This chemical substance acts as a protective osmolyte, Essentially, it counterbalances the destructive effects of extreme pressure on the fish's proteins and cell membranes. Under normal pressure, proteins maintain specific three-dimensional shapes that are crucial to their function. Under extreme pressure, those shapes would collapse and proteins would stop functioning, killing the cell. TMAO literally stabilizes these protein structures, preventing them from being crushed and deformed by apocalyptic pressure. It's like having an invisible molecular exoskeleton protecting each individual cell. And far from being a passive victim desperately struggling to survive, this ghostly fish is actually an apex predator in its specific ecosystem, an active and efficient hunter that voraciously feeds on small crustaceans and amphipods that share its abyssal habitat. It doesn't just survive extreme depths, it completely dominates its ecological niche, reigning as one of the apex predators of the Hadal world. The Mariana snailfish is living proof that appearances can be mortally deceiving. Creature 2, the giant amphipod, Alicella gigantea, the super-sized scavenger of the abyss. You've probably seen amphipods in your life without even knowing their name. Know those little beach fleas or sandhoppers that energetically jump on the wet sand when you walk along the beach at sunset? Those tiny creatures, the size of a grain of rice or maybe a lentil, that hop around and curl into little balls when threatened? Those are shallow water amphipods, relatively simple and harmless crustaceans. Now take that comfortable, familiar mental image and prepare to have your mind completely blown. Imagine one of those little amphipods, but amplified, expanded, super-sized to over 12 inches in length. 12 inches. That's the size of a complete school ruler, bigger than your open hand with fingers extended, approximately the length of an iPad. Welcome to the absolutely surreal and slightly terrifying world of the deep-sea giant amphipod, magnificently represented by the species Alicella gigantea and its close relatives. This biological phenomenon called abyssal gigantism, where creatures that are tiny in shallow water grow to absurdly large sizes in the depths, still isn't completely understood by scientists, but is probably related to the combination of slow metabolism, extreme longevity, constant cold temperatures, and scarcity of predators. These gigantic crustaceans are the official scavengers of the abyss, the essential cleanup crew, the vultures of the Hadal zone, responsible for recycling any organic matter lucky or unlucky enough to reach the bottom. When a large carcass, say a dead fish, a sunken dolphin, or very rarely the absolute jackpot that is a dead whale, manages to make the long journey of miles through the water column and finally lands on the muddy bed of the bottom, something absolutely fascinating and slightly disturbing happens. Somehow, through incredibly acute chemical senses that can detect decomposition molecules dissolved in the water at distances of potentially miles, the giant amphipods appear. Not one or two, but hundreds, sometimes thousands of them, emerging from the surrounding mud and converging on the carcass in dense, frenzied swarms. They completely cover the dead body like a living, pulsating blanket, devouring the flesh with terrifying efficiency that would make piranhas look like polite, slow eaters. A carcass that would take weeks to naturally decompose can be completely skeletonized, reduced to clean bones, in a matter of hours by the starving amphipods. It's biological recycling in turbo mode, a desperate feast at the bottom of the world where food is so rare it can't be wasted. But here's the million-dollar scientific question marine biologists were asking. How does these crustaceans' outer shell, their chitinous exoskeleton, manage to withstand crushing pressure without being compressed and crushed? The answer, discovered only recently through detailed chemical studies published in 2020, is as bizarre as it is brilliant. They literally bioaccumulate aluminum. Yes, the same silvery metal used in soda cans and aluminum foil. which they absorb from the mineral-rich clay on the seafloor and use it to create a protective gel of aluminum hydroxide that permeates and reinforces their exoskeleton. They essentially build molecular metal armor to survive. The creatures of the Mariana Trench are true masters of chemistry and extreme survival. Creature 3. The xenophyrophore, the giant unicellular amoeba. Prepare now for a creature that will completely, absolutely, fundamentally challenge your basic definition of what it means to be an organism. When you look at a xenophyrophore for the first time in a photograph from the seafloor, the first impression is that you're looking at a weird marine sponge, perhaps a small bizarre coral of irregular shape, or possibly some kind of aquatic fungus or interesting mineral structure. It looks like an amorphous mass, somewhat bulbous, often with branching extensions, covered with sand grains and debris stuck to the surface. It doesn't look particularly alive, to be honest. But here's the absolutely, completely, incomprehensibly insane fact that will make you question everything you learned in middle school biology class. This thing you're looking at, this entire complex and branching structure, isn't a colony of organisms working together like coral or sponges. It's not a multicellular animal with trillions of cells cooperating. This is one single individual cell, a giant amoeba, a unicellular organism that can grow and reach the size of a tennis ball, easily 4 inches in diameter or more. For context, the average human cell is about 10 micrometers in diameter. You'd need 1,000 of them lined up to cover 1 centimeter. The xenophyrophore is literally 10,000 times larger than that. It's like comparing an ant to the Empire State Building in terms of relative scale. They're officially recognized as the largest known unicellular organisms in the entire world, defying all the rules we thought governed cell size. But how does a single cell manage to grow so large without imploding under its own metabolic weight or losing the ability to transport nutrients? Xenophyrophores solved this problem through a brilliant architectural strategy. They have multiple nuclei, they're multinucleated, scattered throughout their giant cytoplasm, allowing distributed genetic control like multiple command centers operating in coordination. They survive by patiently absorbing organic nutrients from the surrounding muddy sediments through their massive cell membrane, essentially feeding on the marine snow that constantly accumulates on the bottom. But perhaps the most fascinating and creative part of these organisms is that they literally build their own house, their own outer protective structure called a test. They do this by meticulously gluing sand grains, mineral particles, broken shell fragments, and the calcareous microscopic skeletons of other dead organisms like foraminifera and radiolarians, using a sticky organic secretion they produce. It's cellular architecture, civil construction executed by a single cell. Different species of xenophyrophores create tests with distinctly different shapes, textures, and patterns, as if each species had its own preferred architectural style. They're simultaneously the architects and builders of Earth's deepest place, proving that structural complexity doesn't necessarily require multicellularity. And they're just one cell doing all this alone. Creature 4, the ethereal sea cucumber, Holothurian, the translucent ghosts of the abyss. The sea cucumbers most people know from shallow coastal waters or public aquariums are frankly uncharismatic and not particularly beautiful creatures. They literally look like fat, dark sausages slowly crawling along the seafloor, sucking mud through the mouth at one end and expelling processed mud from the other end in an existence that seems extraordinarily monotonous and uninspiring. They're the biological vacuum cleaners of the ocean, ecologically useful, but hardly exciting to observe. Now, completely forget that image because the sea cucumbers inhabiting the Hadal zone of the Mariana Trench are creatures from literally another world in terms of appearance and behavior. Many of the Hadal species, are almost completely translucent, with bodies so transparent they look like living glass or animated gelatin, allowing you to see clearly through their body wall, the internal organs functioning in real time. You can literally observe their digestive system processing sediments, see the coelomic fluid, their blood equivalent, circulating, and even distinguish muscles contracting and relaxing under the ghostly skin. They have no pigmentation, because pigments serve for UV light protection or visual camouflage, two things completely irrelevant in an environment of perpetual total darkness where there has never been, nor will there ever be, sunlight. But here's where it gets truly magical and surreal. Some genera of deep-sea sea cucumbers, particularly those of the genus Enypniastes, affectionately nicknamed headless chickenfish by scientists due to their bizarre appearance when filmed, evolutionarily developed something that seemed impossible for a sea cucumber: the ability to swim freely through the water column. They literally detach from the muddy seafloor, inflate modified extensions of their body that function like veils or membranous wings, and float gracefully through the darkness like translucent aquatic ghosts or jellyfish gliding in a silent, solitary ballet. Footage from depth cameras shows them undulating and pulsing through the abyss in a hypnotic, otherworldly dance, potentially traveling miles in search of patches of seafloor with sediments richer in nutrients or less competition for food. It's such an unexpected behavior, so counterintuitive for an animal supposed to be a slow bottom crawler, that the first scientists who saw the footage literally didn't believe what they were seeing. These are truly ethereal creatures, ghostly inhabitants of the abyss that seem to exist halfway between solid and liquid, between living and spectral. Creature 5. The true supreme kings of the abyss, the invisible microbes. The translucent snailfish are incredible in their resilience. The giant amphipods are impressive in their size and voracity. The xenophyophores defy conventional cell biology. The ethereal sea cucumbers are visually hypnotic. But let's be completely honest and scientifically accurate here. The true, undisputed, absolute and unquestionable owners of the Mariana Trench are organisms so small they're completely invisible to the naked eye. We're talking about microbes, unicellular bacteria and archaea, those domains of life that existed billions of years before the first multicellular animals even evolved. The trench bottom isn't just populated by microbes, it's absolutely stuffed, saturated, packed with them in densities reaching millions or even billions of cells per cubic centimeter of sediment. Each handful of mud from the bottom contains more microbial cells than there are humans on the entire planet Earth. And these aren't normal, common, boring microbes you'd find in your garden soil or on your skin. No, these are extremophiles of a special and specific category that microbiologists call piezophiles or barophiles, words derived from Greek literally meaning pressure lovers. These microbes don't just passively survive crushing pressure of 1,000 plus atmospheres. They actively love, require, depend on that extreme pressure to live, grow, reproduce, and thrive. Their cell membranes have a unique lipid composition, enriched with special polyunsaturated fatty acids that remain fluid and functional under extreme pressure where normal lipids would solidify. Their proteins are adapted with modified three-dimensional structures that function optimally under compression. And here's the truly mind-blowing part that demonstrates how perfectly adapted they are to the abyss. If you took these pisophilic bacteria from the bottom of the Mariana Trench, carefully placed them in a test tube, and quickly brought them to the surface to our normal, comfortable atmospheric pressure of 1 atmosphere, they would simply die. Cell membranes would disintegrate, proteins would stop functioning correctly, and cells would collapse and die as surely as a human would die if exposed to space vacuum. For these microbes, normal surface pressure is lethal. It's the extreme environment. It's the deadly vacuum. Their normal is 1,000 atmospheres of crushing pressure. They live in a completely inverted universe from our expectations. And these invisible microbes are the absolute base, the fundamental foundation of the entire extreme Hadal ecosystem. They're the essential first link of a food chain operating completely independently of the sun, recycling nutrients, decomposing organic matter, and even producing chemical compounds that other larger organisms can use as energy. Without these microscopic microbes, none of the larger, more visible creatures could exist. They're the true invisible masters of the deepest place on Earth, proving that size absolutely doesn't matter when it comes to ecological importance. What exists at the seafloor at the microscopic level is as or more fascinating than the strangest creatures in the ocean we can see. Here's a question that should make you stop and really think deeply for a moment. How can an entire ecosystem, complete and functional, with primary producers, consumers, predators, and decomposers, not only survive, but genuinely thrive under conditions of zero, absolutely zero sunlight? Think about that seriously. Since kindergarten, we've been taught that the sun is the fundamental, primary, and irreplaceable source of energy for virtually all life on Earth. Plants and algae photosynthesize, capturing solar energy and transforming it into sugars and organic matter. Herbivores eat the plants. Carnivores eat the herbivores. We eat both plants and animals. The entire food pyramid, the entire trophic web of the planet, ultimately traces its energy back to the bright sun in the sky. It's the golden rule of biology, the fundamental axiom of ecology. Except that it's not, because at the bottom of the Mariana Trench and in other similar extreme environments around the planet, life has found a completely different, radically alternative, and absolutely fascinating way to generate energy and build organic matter from scratch without ever in millions of years, needing a single ray of sunlight. The answer to this apparent biological impossibility is concentrated in surreal oases of life that arise in the most unexpected, most unlikely, and geologically violent places on the ocean floor. Hydrothermal vents, also romantically known as black smokers or submarine chimneys. And the revolutionary biochemical process that happens there has a name every biology student should know, but few really understand: chemosynthesis. Hydrothermal vents are essentially fissures, cracks or openings in the seafloor, especially common and active in zones of intense tectonic activity like mid-ocean ridges, where tectonic plates are moving apart, or subduction zones like the Mariana Trench itself, where plates are colliding. From these fissures gushes superheated water at temperatures that literally defy logic, often exceeding 752 degrees Fahrenheit, sometimes reaching absurd 867 degrees at some extreme vents. Wait, you must be thinking, doesn't water boil at 212 degrees? How can liquid water exist at 750 degrees without instantly turning to steam? The answer is again the extreme pressure of the deep sea floor. The immense pressure of hundreds or thousands of atmospheres dramatically increases water's boiling point, allowing it to remain in liquid state even at temperatures that at the surface would instantly transform it into explosive vapor. This superheated water doesn't come directly from the ocean. It's seawater that infiltrated through cracks in the oceanic crust, descended miles through porous rock until encountering magma chambers, was heated to infernal temperatures, dissolved absurd amounts of minerals, iron, manganese, copper, zinc, sulfur, and hydrogen sulfide from surrounding rock, then was violently forced back to the surface by pressure until gushing into the freezing ocean. When this superheated chemical water contacts the surrounding freezing ocean water at just 36 to 39 degrees Celsius, dissolved minerals instantly precipitate, creating those dramatic plumes of black or white smoke that give the vents their poetic names. For us, humans and the vast majority of organisms on Earth, hydrogen sulfide, H2S, is an absolutely deadly and repugnant poison. It's that toxic gas with the distinctive, nauseating smell of rotten eggs that makes you feel like vomiting instantly. Breathing high concentrations can cause respiratory paralysis and death in minutes. It's used as a chemical weapon in some situations, universally avoided and feared. And here lies one of the most beautiful and poetic ironies of biology, for the specialized bacteria living around hydrothermal vents, those that evolved for millions of years in this bizarre chemical environment. Hydrogen sulfide isn't poison. It's food. It's pure energy. It's literally the equivalent of what sunlight is for surface plants. It's a chemical feast they never tire of. These revolutionary chemosynthetic bacteria perform a process that, when you really stop to think about it, is as elegant and fundamental as photosynthesis, just using a completely different energy source. If photosynthesis uses energy from sunlight captured by chlorophyll to break water molecules and fix carbon dioxide into organic sugars, chemosynthesis uses energy released by chemical reactions, specifically the oxidation of hydrogen sulfide, ammonia, or methane, to perform essentially the same miraculous transformation. Take inorganic carbon dioxide dissolved in water and build complex organic molecules like sugars and amino acids. They literally, without exaggeration or metaphor, transform deadly poison into nutritious food, transform toxins into life. This apparently simple but profoundly revolutionary chemical process creates something absolutely extraordinary in the midst of abyssal desolation. Verdant oases, though verdant is metaphorical since there are no green plants, of exuberant biodiversity flourishing in total darkness and perpetual cold, completely disconnected and independent from the sunlit surface miles above. They're literally entire cities, underwater metropolises of exotic and highly specialized creatures living exclusively around these smoking chemical fountains. The diversity of life, concentrated within a few yards around an active hydrothermal vent, can rival that of a tropical coral reef, except this reef exists in complete darkness, deadly cold except immediately next to the hot vent, and crushing pressure. We find there absolutely bizarre giant tube worms, species of the genus Riftia, that can reach truly impressive lengths of over 6 feet tall. Imagine a bright red, fleshy tube the size of a standing person. And here's the part that will make your head spin. These worms have no mouth, no anus, no functional digestive system whatsoever. Zero. So how the hell do they feed and obtain nutrients? The answer is a symbiosis so intimate, so completely integrated, that it blurs the lines between individual organism and cooperative ecosystem. About 50% of the total body weight of an adult Riftia worm is composed of a giant specialized organ called the trophosome, which is literally packed, stuffed, absolutely crammed with symbiotic chemosynthetic bacteria living inside it. The worm absorbs toxic hydrogen sulfide through specialized gill-like structures at its exposed end, transports it through modified hemoglobin in its blood, which gives that vibrant red color, to the trophosome, and literally feeds the bacteria with toxic chemicals. The bacteria, in turn, perform chemosynthesis and produce nutritious organic compounds that the worm directly absorbs. It's a perfect partnership, an absolute mutual dependency. The bacteria can't survive without the worm providing chemicals and shelter. The worm can't survive without the bacteria producing food. It's life within life, a composite organism functioning as a single unit. And tube worms are just the beginning of this hydrothermal zoo. We also see blind albino crabs of the genus Kiwa, nicknamed Yeti crabs, due to their claws covered with white hair-like bristles that shelter their own symbiotic bacteria that they'd farm by waving their claws near the vents to feed them with chemicals. There are translucent shrimp that exist in such high densities around the vents. They look like living, pulsating clouds, some with rudimentary, light-sensitive organs, not for seeing in the normal sense, but to detect weak thermal radiation emitted by the hot vents. There are mussels and bivalve mollusks with their own symbiotic bacteria housed in the gills. There are specialized fish, octopuses, anemones, and literally hundreds of species still being discovered and catalogued by science. Each hydrothermal vent is essentially a miniature planet with its own unique ecosystem, and vents separated by just miles can have completely different species communities, evolving in isolation like separate biological islands in an ocean of sterile darkness. The creatures of the oceanic abyss proved that beings living without sunlight don't just exist. They thrive in diversity and complexity, rivaling sunlit ecosystems. This scientific discovery of hydrothermal vents and chemosynthesis, first made in 1977 when the submersible Alvin explored the Galapagos Ridge and literally stumbled upon these unexpected communities, is considered one of the most profound, important, and revolutionary biological discoveries in all of modern science history. It fundamentally rewrote the rules about where and how life can exist. It irrefutably proved that life on Earth does not necessarily need the sun. Photosynthesis isn't the only path. Chemistry can replace light, and this has philosophical, scientific, and astrobiological implications that go immensely beyond our own blue planet. Icy moons orbiting giant planets in our own solar system, particularly Europa, one of Jupiter's moons, and Enceladus, one of Saturn's moons, possess vast oceans of liquid, salty water hidden beneath thick layers of surface ice miles thick. There's no sunlight penetrating that ice to the dark oceans below, but measurements and scientific models strongly suggest there may be active hydrothermal vents on the rocky ocean floors of these moons, powered by tidal heating generated by the immense gravity of the giant planets orbiting them. The Mariana Trench, its smoking hydrothermal vents, and the bizarre chemosynthetic communities thriving around them are literally our best, closest, and most accessible terrestrial analog for how extraterrestrial life could exist in those hidden alien oceans. When we eventually send robotic probes to drill through Europa's ice and explore the ocean below, scientists will be specifically looking for signs of chemosynthesis and communities similar to those we discovered in our own abyss. Extreme life at the bottom of Earth's ocean is literally teaching us how to look for life on other worlds. The Mariana Trench creatures are ambassadors of the possibility of universal life. We could reasonably think, assume with confidence, and even bet money that Earth's most remote, most inaccessible, deepest, and most isolated place, an abyss 7 miles below the ocean surface that literally fewer people have visited than the moon, would be completely pristine, untouched by human presence and its inevitable environmental impacts. Makes logical sense, right? If we can barely get there, if it requires cutting-edge technology and million-dollar budgets just to make a single descent, surely our destructive influence couldn't have reached that remote sanctuary of nature. Surely the bottom of the Mariana Trench would be one of the last truly virgin places on the planet, a final refuge from human civilization and its consequences. Right? Wrong. Terribly, sadly, shamefully wrong. The reality is so shocking, so profoundly disturbing, and so symbolically devastating that it should serve as a deafening alarm for all humanity about the truly global reach of our environmental footprint. Because it turns out our presence, our trash, our invisible chemical pollution managed to reach Earth's deepest place long before we properly explored and studied the extraordinary life existing there. It's a race we lost humiliatingly. Our trash arrived before our scientific curiosity. In May 2019, when explorer and former U.S. Navy officer Victor Vescovo completed his historic record-breaking dive to the absolute bottom of Challenger Deep in the Mariana Trench, becoming only the third person in history to personally witness that alien landscape at 35,153 feet deep. He was naturally focused on observing the fascinating geology, looking for bizarre life, and documenting this extreme environment for science. He had high-definition cameras filming, powerful LED lights illuminating the perpetual darkness, and was transmitting his observations to the scientific team on the surface with palpable excitement. And then, about 3 hours into his exploration of the muddy bottom, something completely unexpected and profoundly depressing appeared in the field of view of the submersible's external cameras. It wasn't a bizarre deep-sea creature. It wasn't an interesting geological formation. It was something painfully, unmistakably, shamefully familiar. A common plastic shopping bag, the kind you get at supermarkets, partially buried in the grey mud and gently swaying in the weak current. Beside it, colourful candy or snack wrappers, recognizable even covered in sediment, mundane, trivial, disposable human trash at the deepest point on the planet. Let that image sink into your consciousness for a moment. Our disposable plastic trash, probably carelessly thrown from a ship or washed from a beach through a river, managed to make the 7-mile journey through the water column, a trip that takes days or weeks of slow sinking, and land in Earth's most inaccessible place before we could properly explore it. It's a brutal metaphor for the Anthropocene, the geological era defined by human impact. But as symbolically devastating as finding a visible plastic bag at the bottom of the abyss is, the story of pollution in the Mariana Trench gets even darker, more insidious, and more scientifically alarming when we look at invisible contamination to the naked eye, chemical pollution, and microplastics that permeate the entire ecosystem. Years before Vescovo's discovery, in 2017, a team of researchers from Newcastle University in the UK, led by Dr. Alan Jameson, one of the world's leading experts in hadal ecology, conducted a systematic and disturbing study. They captured live amphipods, those scavenger crustaceans we mentioned earlier, from various deep oceanic trenches around the world, including the Mariana Trench, the Japan Trench, and the Kermadec Trench near New Zealand, using specially designed baited traps. Back in the laboratory, they carefully dissected these small animals and analyzed the contents of their stomachs and tissues using advanced spectroscopy techniques. What they discovered was shocking in its scope. All the amphipods analyzed, without a single exception, 100% of samples collected from depths between 20,000 and almost 36,000 feet contained synthetic plastic microfibers in their digestive systems. Not some, not most, all. Microplastic contamination was universal, ubiquitous, and inescapable, even 7 miles deep in the ocean. These small plastic fragments, many of them microscopic fibers measuring less than 0.2 inches deep, came from depressingly mundane sources. Washing synthetic clothes, which releases thousands of polyester and nylon microfibers each cycle. Degradation of abandoned fishing nets. Fragmentation of larger plastic packaging, and countless other sources of plastic pollution we dump into the oceans at a current estimated rate of 8 to 12 million tons per year. The discovery was so significant and symbolically powerful that when scientists formally identified and described a new species of amphipod collected at a depth of approximately 22,600 feet in the Mariana Trench, they made a deliberate and conscious decision to give this newly discovered creature a scientific name that would serve as a permanent memorial, an eternal warning inscribed in biological nomenclature about human impact. They named the new species Eurythanes plasticus. It's not a pretty name. It's not poetic or inspiring. It's brutally direct and intentionally provocative. The choice of the specific epithet, plasticus, leaves no room for doubt about the reason. The first specimen of this species examined and designated as the holotype, the official reference specimen, had PET fibers, polyethylene terephthalate, the same transparent plastic used in water bottles, sodas, and synthetic athletic wear, clearly visible inside its digestive tract when dissected. The scientific name of this new life form, officially catalogued in taxonomic records and remaining forever in scientific literature, will be eternally linked to our plastic trash. Every time a future scientist mentions Eurythanes plasticus in a paper, every time a student looks up this species in a database, they'll be reminded of human pollution. It's a permanent indictment disguised as Latin nomenclature, an epitaph for the lost innocence of Earth's last wild place. And sadly, appropriately, it's one of the bizarre creatures from the deep sea whose very name carries humanity's mark. But wait, because the situation is even worse than visible plastics and microplastics in crustacean stomachs. The invisible chemical pollution of the Mariana Trench reaches levels that are, frankly, incomprehensible and scientifically alarming. In 2017, another bombshell study published in the prestigious scientific journal Nature, Ecology and Evolution by an international team of researchers chemically analyzed fatty tissues of amphipods and other organisms collected in the Hadal zones of the Mariana and Kermadec trenches. They were specifically looking for POPs, persistent organic pollutants, a class of notorious synthetic chemical compounds that include PCBs, polychlorinated biphenyls, and PBDEs, polybrominated diphenyl ethers. These chemicals were widely used industrially for decades in electrical insulation, hydraulic fluids, flame retardants, and countless other applications before being progressively banned or severely restricted starting in the 1970s and 1980s due to their toxic effects, bioaccumulation capacity, and extreme environmental persistence. They don't degrade easily. They accumulate in food chains, and even decades after being banned in most developed countries, they still circulate globally through ocean and atmospheric currents. The analysis results were absolutely shocking. PCB concentrations found in the tissues of Hadal amphipods from the Mariana Trench were, in some individual cases, 50 times higher, 50 times, than concentrations found in crabs living in some of China's most infamously polluted and industrialized rivers, including areas near heavy industrial zones known for severe chemical contamination. How the hell is that possible? How do creatures living in the planet's most remote and deep place manage to have higher chemical pollution levels than animals living literally next to polluting factories? The scientific explanation is simultaneously elegant and profoundly depressing. POPs are chemical compounds that have two key properties. They're hydrophobic, repel water, and lipophilic, attracted to fats. When released into the environment through industrial discharges, landfill leaching, or degradation of old products, they eventually find their way to the ocean through rivers and runoff. Once in the ocean, they adhere to organic particles, fragments of dead plankton, feces of marine animals, essentially any matter containing lipids, and all that organic matter, that marine snow we mentioned earlier, slowly sinks through the water column, taking chemical pollutants along. Deep oceanic trenches, including the Mariana Trench, act geologically as sediment traps, or sinks. Once material falls in there, it tends to stay there, accumulating over decades. It's as if the trenches were giant drains at the ocean bottom, concentrating decades of global pollution in a confined space. And because amphipods and other hadal organisms voraciously feed on this contaminated marine snow, they ingest and bioaccumulate POPs in their fatty tissues at increasingly higher concentrations through biomagnification processes throughout their relatively long lives. The very strangest creatures in the ocean are being slowly poisoned by chemical waste we dumped decades ago, in some cases before many of us were born. Our toxic legacy reached what lives at 7 miles deep long before our environmental awareness. The cruel irony of all this, the Shakespearean tragedy that should make any sensible person pause and reflect, is that we're actively polluting, contaminating, and potentially destroying entire ecosystems in the abyss that we've barely begun to study and understand. Each passing year, courageous marine scientists using advanced submersibles and ROVs, remotely operated vehicles, are discovering new species of bizarre deep-sea creatures in the Mariana Trench and other hadal zones at an impressive rate. Estimates suggest perhaps only 10 to 20% of hadal biodiversity has been documented so far. Each expedition brings back creatures science has never seen before, animals with unique biological adaptations that could have implications for biotechnology, medicine, materials science, and our fundamental understanding of life's limits. Enzymes functioning under extreme pressure could revolutionize industrial processes. Bioactive compounds produced by hadal microbes could be the next generation of antibiotics. These creatures' survival strategies could inform design of pressure-resistant materials for underwater engineering. But before we even fully catalogue what exists down there, before we fully comprehend the deep-sea mysteries the trench hides, we're already dumping plastics, toxic chemicals, and altering the environment through ocean acidification caused by excess atmospheric CO2 dissolving in the water. It's like burning an ancient library before reading the books, destroying a treasure before understanding its value. The animals of the Mariana Trench deserve better than this. They survived millions of years of brutal evolution, adapted to Earth's most extreme imaginable environment, and now face a threat evolution didn't prepare them for: us. We've just made together an absolutely extraordinary vertical journey, meticulously descending through 7 complete miles of pressurized ocean until reaching the dark, frozen, and crushingly heavy heart of our own planet. We departed from the sunlit, familiar surface, crossed the twilight zone where sunlight slowly dies, plunged through perpetual midnight where bioluminescence reigns, descended even deeper through the desolate abyss, and finally reached the hadal zone, that mythological realm of Hades where, theoretically, nothing should survive. We initially went searching for monsters straight from ancient sailors, legends, colossal creatures with tree-sized tentacles or jaws capable of swallowing entire ships. We expected perhaps to find a sterile biological desert, a cold, lifeless oceanic cemetery. But what we actually found, what scientific reality revealed to us through high-definition cameras and carefully collected samples, was something infinitely more precious, more surprising, and more deeply inspiring than any fictional monster could be. We found walking miracles of evolution, biological masterpieces sculpted by millions of years of brutal selective pressure. Translucent, ghostly snailfish that seem made of living glass, but transform molecular chemistry to survive the absolutely impossible. Gigantic crustaceans building metal armor from seafloor mud using bioaccumulated aluminum like microscopic biological blacksmiths. Organisms of a single giant cell the size of your fist that build elaborate architectural homes by gluing sand grains and skeletons of dead microbes. Ethereal sea cucumbers that develop the impossible ability to gracefully fly through dark water like aquatic ghosts in slow motion. And trillions upon trillions of invisible microbes that literally love crushing pressure, that would die at our normal surface, and that form the invisible but essential base of this entire extreme functioning ecosystem. The Mariana Trench and its bizarre but resilient inhabitants show us, prove to us irrefutably and scientifically verifiably that life on this planet is infinitely more resilient, more adaptable, more creative, more ingenious, and more stubbornly persistent than our limited imagination could ever conceive alone. Life finds paths where there should only be dead ends. It thrives where it should only agonize. It evolves brilliant solutions to problems that seem unsolvable. Each of these bizarre deep-sea creatures is a living, breathing, functioning testament that the limits we think exist are often just limits of our own current understanding, not fundamental limits of biological reality. The Mariana Trench creatures teach us scientific humility. They exist and thrive under conditions that decades of biologists declared impossible with absolute confidence. They constantly remind us that approximately 80% of the total volume of our own ocean, the ocean covering 71% of the planet's surface we call home, continues to be a complete, absolute, and embarrassing mystery to us. Less than 25% of the global ocean floor has been mapped at resolution comparable to what we have of Mars or the Moon. We literally have more detailed maps of Venus's surface, a hostile planet covered in sulfuric acid clouds 450 million miles away, than we have of the seafloor just a few miles below our own boats. It's an entire universe of biodiversity, geology, chemistry, and potentially paradigm-changing discoveries waiting to be explored right here at home without needing spaceships or interplanetary travel. What exists at the seafloor continues being one of humanity's last great frontiers of exploration, and each dive reveals wonders that rewrite textbooks. But in that same abyssal darkness that should be pristine and untouched, in that place that should be safe from human influence by simple virtue of its extreme inaccessibility, we also found something profoundly disturbing, shameful, and impossible to ignore. A dark and accusing reflection of ourselves. We found our own disposable trash scattered at the bottom of the world, supermarket plastic bags swaying in the current at 36,000 feet deep, colorful candy wrappers partially buried in primordial mud, microplastics permeating every examined creature without exception. We found toxic chemical pollutants we banned decades ago accumulated in amphipod tissues at concentrations exceeding those of animals living in polluted industrial zones. We discovered we managed to poison Earth's deepest place before even properly exploring it, before cataloguing its biodiversity, before fully understanding its ecological and scientific importance. This discovery isn't just an interesting scientific curiosity to publish in obscure academic journals. It's a brutal, unequivocal, and terrifying reminder of a fundamental truth humanity desperately needs to internalize. There is no magical away where we can conveniently throw our unwanted things and forget about them. There is no far where trash simply disappears from existence. Our planet is a closed, finite, and interconnected system, a fragile blue spaceship orbiting through cosmic vacuum. And our actions, however distant they may seem from consequences, however diluted we think they become, eventually return and accumulate in the most unexpected places. Global ocean currents don't respect national borders or distances. Pollution you discard on a beach in New York can eventually sink to the bottom of the Mariana Trench in the Western Pacific. Plastic you throw in the trash in Paris can end up in an amphipod's stomach 6 miles deep. We're all connected through this global ocean, and what we do up here inevitably affects what lives at 7 miles deep. This is infinitely more than just a fascinating scientific curiosity about strange creatures living in extreme places, more than educational entertainment to fill 20 minutes of your day. This is a deafening emergency alarm, ringing at a frequency that should make all humanity wake up startled and pay urgent attention. The Mariana Trench, that deepest, most mysterious, most apparently isolated and inaccessible place on our planet, is literally watching us in crushing silence through the lenses of submersible cameras that finally managed to get there. And what it shows us, what it reflects back at us through its freezing dark waters, isn't just life's wonderful resilience or extreme evolution's fascinating strangeness. It shows us a dual and contradictory reflection of ourselves as a species. On one hand, our incredible, admirable, and inspiring human capacity to explore, discover, do rigorous science, build impressive technologies that allow us to visit these impossible realms and expand the horizons of human knowledge. On the other hand, it shows us our equally amazing, deeply concerning, and apparently unlimited capacity to pollute, contaminate, degrade, and potentially destroy even the most remote ecosystems through negligence, rampant consumerism, and lack of systemic thinking about long-term consequences. Extreme life at the ocean bottom survived millions of years of brutal evolution, adapted to pressures that crush metal, thrived in perpetual darkness without sunlight, found ingenious ways to transform chemical poison into vital energy. But all that evolutionary resilience didn't prepare it to face the avalanche of plastic and chemical pollution that industrialized humanity dumps into oceans at accelerated rates. The strangest creatures in the ocean, those biological wonders adapted to the extreme, are now vulnerable not to pressure, not to cold, not to darkness, but to us. The Mariana Trench isn't just a place on the map. It's a mirror. It's a character test for the human species. It's a silent but deafening question. Will we choose to be curious explorers, rigorous scientists, responsible stewards of this extraordinary planet? Or will we be negligent polluters, insatiable consumers, unconscious destroyers even of the last wild places? The answer to that question is still being written by our daily actions, by the policies we support, by the products we buy, by the trash we generate and discard. The oceanic abyss is watching. The beings living without sunlight are silently judging us through the plastic microfibers in their stomachs. And the question remains, what legacy will we leave for future generations and for the bizarre creatures from the deep sea that share this planet with us? We can do better. We need to do better. We must do better, because if we can't protect even Earth's deepest and most isolated place from our pollution, what does that say about our ability to protect anything? The Mariana Trench and its extraordinary inhabitants deserve more than our plastic bags and chemical pollutants. They deserve respect, protection, and the chance to continue evolving in their abyssal realm without destructive interference from the surface. And we, as the only conscious species capable of understanding and acting on these issues, have the moral and ethical responsibility to ensure that the abyss is calling. The question is, will we respond with wisdom or with more trash? So, my friend, we've reached the end of this absolutely extraordinary vertical journey through 7 miles of pressurized ocean to the pulsating heart of Earth's deepest abyss. You've just witnessed something the vast majority of people on this planet will never have the opportunity to know in detail. A complete and immersive dive into the depths of the Mariana Trench, personally meeting the bizarre deep-sea creatures thriving where science declared life impossible, understanding the deep-sea mysteries that rewrite biology's rules, and confronting the uncomfortable truth about how our pollution reached even the planet's most inaccessible place. You met the ghostly snailfish manipulating molecular chemistry to survive the impossible, came face to face with giant amphipods building metal armor, marveled at tennis ball-sized unicellular amoebas that are solitary architects, saw ethereal sea cucumbers gracefully flying through perpetual darkness, learned about trillions of invisible microbes that literally love crushing pressure, and discovered the revolutionary miracle of chemosynthesis, life flourishing completely independent of the sun through pure chemical energy. You didn't just read about these creatures, You traveled with them, descended through each oceanic zone, felt the weight of increasing pressure, witnessed sunlight dying and total darkness taking over. Now here's my question. If you think these otherworldly creatures are incredible, fascinating, worthy of admiration and study, if you believe this extraordinary oceanic abyss deserves our protection, respect, and the chance to exist without being suffocated by our plastic and poisoned by our chemicals, then do something simple but powerful right now. Smash that like button with all the force you've got. Each like isn't just a meaningless number on a screen. It's a vote of confidence. It's you saying, yes, this knowledge matters. It's you amplifying this message so more people can discover the wonders and warnings from the bottom of the world. It's you directly contributing to ensuring this type of deep, well-researched, transformative educational content continues being created and widely shared. Social media algorithms respond to engagement. The more you interact, the more people will be exposed to this vital information about Mariana Trench creatures and the urgent need to protect them. And please, don't stop at just the like. I want to know. I really want to hear from you in the comments down here. Which of these creatures from the oceanic abyss surprised you most deeply? Was it the translucent snailfish with its defensive TMAO molecular chemistry? Was it the gigantic amphipods building aluminum armor like biological blacksmiths? Was it the massive unicellular amoeba that's literally a single architect cell? Was it the ghostly sea cucumbers that learn to fly in darkness? Or maybe it was the invisible piezophilic microbes that would die at our normal pressure because they're too adapted to the extreme? Write in the comments, share your reaction. Tell me which creature blew your mind. Tell me what you found most fascinating or disturbing about pollution reaching the trench bottom. I love reading each comment, responding when I can, and creating a community of people genuinely curious about the animals of the Mariana Trench and committed to ocean protection. Each comment you leave also feeds the algorithm, dramatically increasing the chances this video reaches people who desperately need to see this message, but don't yet know they need to. And look, if you made it this far, if you watched or read to this final point when you could have quit long ago, that tells me something important about you. You're genuinely curious. You value deep knowledge over disposable superficial entertainment. You care about our planet and the extraordinary life forms inhabiting it. People like you are exactly the type of audience I want to build. Critical thinkers, eternal learners, people unafraid to confront uncomfortable truths about our environmental impact. So here's my final and most important request. Subscribe to this channel now, and this is crucial. Activate that notification bell so you're literally alerted every time we publish new content exploring the most extreme, bizarre, and fascinating corners of our incredible planet. Because believe me when I say the Mariana Trench is just the beginning of this discovery journey. We have so much more to explore together. The smoking hydrothermal vents of the Atlantic where giant tube worms live in symbiosis with bacteria. The supersaturated brine lakes at the bottom of the Gulf of Mexico that are literally lakes within the ocean, so dense you could sink into them. The giant kelp forests of California, where sea otters use stone tools to crack open shellfish. The bioluminescent coral reefs that glow with alien colors under UV light. The massive daily vertical migrations, where trillions of creatures rise miles every night and descend every morning in the planet's largest animal migration. The underwater mud volcanoes that spew methane and harbor ecosystems based on methanotrophic microbes. Each of these places is a universe of wonders waiting to be explored, explained, and protected. And you, by subscribing and activating notifications, ensure you won't miss any of these extraordinary scientific adventures. Every interaction you make, every like, every comment, every share on your social networks, every subscription, isn't just an empty symbolic gesture. Each of these actions has real and measurable impact. They directly help us continue producing high-quality educational content like this, deeply researched, richly detailed, and committed to scientific accuracy instead of cheap sensationalism. They allow us to continue exploring, documenting, and sharing the hidden wonders and urgent warnings of our incredible blue world. They create a global community of informed people who understand that what lives at 7 miles deep matters as much as any other ecosystem. And maybe, just maybe, if enough people learn about these extraordinary creatures and how our pollution is threatening them, we can create the social and political pressure necessary for real changes in plastic waste management policies, chemical pollution control, and ocean protection. So I'll ask one final direct question before we say goodbye. Will you be part of the solution or part of the pollution? Will you choose to be a curious explorer and conscious guardian of this planet, or just another passive consumer who forgets what they learned as soon as they close this video? The choice, my friend, is yours. But I already know the answer. You wouldn't have made it this far if you didn't care. So prove it. Like, comment, subscribe, activate the bell, share with someone who needs to see this. And we'll see you very, very soon on our next expedition to the craziest, most extreme, and most extraordinary places on planet Earth. The abyss is calling, the mysteries are waiting, and the bizarre creatures from the deep sea still have many secrets to reveal. Until the next adventure, stay curious, keep learning, and please take care of our ocean. It's the only one we have.